Hi and Assalamualaikum warahmatullahi wabarakatuh. We would like to present our mini project ECE354. Our project title is Time-Based Light Controller.
Wabarakatuh. My name is Nurul Atina binti Wahid and my student ID is 2022489252.
The introduction of Time-Based Light Controller. This system designed to program the operation of light based on predefined timings. This project is created on the Hairuddin board microcontroller to design an efficient system that can turn the light on or off by employing the internal timer, push button as input port, LED and a buzzer as output port. Firstly, the system enables the user to set a desired time duration on a push button so the LED will remain on, and it will turn off along with a buzzer that will generate a sound after the timer is up. The first push button is configured to set 5 seconds, and the next push button is set 10 seconds, 15 seconds, and 20 seconds. In brief, this innovative system addresses the growing need for versatile, reliable operation and automated solution in managing energy consumption and lighting control by meticulously designing, debugging, and running the code on the HCS 12 Dragon board. Next, purpose of a time-based light controller system. The major purpose of the time-based light controller is to provide automation of lighting according to set timings, with numerous advantages that enhance energy efficiency and user convenience. Also, the system is contributing to environmental sustainability by turning light on when needed, thus significantly reducing unnecessary energy consumption. Automation of lighting does not require any manual controlling of the light, thereby enable the resident to focus on their daily activities without need to remember whether they have to turn the light on or off. Therefore, the system is useful for security purpose by providing adequate light at night to deter any intruder and create a safe living environment for the resident. Overall, the integration of automated lighting system can be applied in various applications and not only contribute to saving energy but also enhance the overall quality of life. Next, we move to significance of the system. The significance of the system is the implementation of energy efficient lighting solution by offering a multitude of advantages that align with contemporary sustainability goals and modern living standards. This solution significantly reduces electricity bill, resulting in substantial savings. Additionally, a time-based light controller plays a crucial role in protecting the environment by minimizing energy waste. Another critical advantage is the safety enhancement that timely lighting in area reduce the likelihood of accident and improve visibility in diverse settings. Energy efficient lighting seamlessly integrate into smart home systems that are more automated and modern lifestyle. This versatility makes such lighting features applicable across diverse environments, including residential homes, business office, industrial factories, and public streets, thereby enhancing both functionality and safety in daily life.
So, the next slide for our mini project, which is time-based light controller, is the circuit design. The figure 1 is the IP switch and push button circuit design. Meanwhile, for the figure 2 is LEDs circuit design, and the last one is figure 3, which is buzzer circuit design. And this is the last figure circuit design for our mini project time-based light controller, which is the main controller to connect all of the components to make sure the program can function well, which is the Dragon 12 layout circuit design.
Based on the figure, the system flowchart of the time-based light controller begins with the initialization of the microcontroller and component, including the push button, LED, timer, and buzzer. The user interacts with the system by selecting a timer duration using one of the push buttons, each corresponding to be a predefined interval such as 5, 10, 15 or 20 seconds, and the microcontroller continuously monitor the push button input until the desired push button, which a specific timer, is pressed. Based on the chosen duration, the system activates a sequence LED patterns, providing a visual running light effect to indicate the timer is in progress. Once the timer duration elapses and the LED sequence complete, the system activates the buzzer to give an audible alert signaling the end of the timer cycle. The process then concludes with the system returning to an idle state ready for further user interaction. This flow ensures a simple yet efficient operation, combining visual and auditory feedback for effective lighting control automation.
This is the coding flowchart for our time-based light controller, which is our mini project for the ECE. In order to start the program, we need to put a start for the main program, and then we need to configure the port that are used in this mini project. So the components that we use is LEDs, push button, and buzzer. We configure port B as input, which is the LEDs. Meanwhile, port H and port T as output, but port H is push button, port T is buzzer. After we have configured the port, at the main loop, we will read button input from port H. Port H is the push button port. And then after we read the button, we need to clear control register such as port J and port T for initial setup, and then check the status of the push button and set the timer for each button. If the button 1 is pressed, we need to load LED sequence pointer into X register. After load the LED sequence, the LED will run according to the timer. For the button 1 is set to 5 seconds, and after the timer is up, the buzzer will activate, will sound, and then the condition for button 1 is applied to the next push button, which is the push button for button 2, button 3, and button 4. After all of the buttons is being pressed, it will return to the main loop, and the condition will loop again until the push button that is desired is pressed. But for button 2 is set for 10 seconds, button 3 is set for 15 seconds, and the last button, which is button 4, is set for 20 seconds. So after all the button has been pressed, the program will end. From what you have been heard on the previous slide, this is the coding flowchart. So this is the coding with command that we need to program for this mini project time-based light controller. Firstly, we need to include the library and then set the memory origin for variables and also for program instructions, which is 2000. And then we need to configure the port for input and output. And then next is the main loop condition to make sure the press can be pressed according to the desired push button. And then next, furthermore, this is the condition for button 1, button 2, button 3, and the last push button. And after the push button condition is the LED loop, which is the LED will running light after the button is being pressed based on the timer that have been set. For button 1 is 5 seconds, button 2 10 seconds, button 3 and 4 are 15 and 20 seconds. And next is the buzzer condition, which is it will make a sound after the timer is up.
This is the result of time-based light controller.
For our discussion that we can talk about for this mini project is the code handles button press to trigger specific timer routines. Second is LED patterns display on HCL12 Dragon board. Lastly is the buzzer will activate when the selected timer on push button already ends. Furthermore, from the discussion, the time-based light controller is implemented on HCS12 Dragon board, demonstrates an effective use of microcontroller technology for automating lighting system. Overall, the system will responding to button presses by activating specific LEDs, sequence and accompanying buzzer for auditory feedback. And then the structural program flow have a featuring suitable subroutines for each button's functionality, ensures efficient operations and timely execution, enhancing the user experience to use the time-based light controller using the HCL12 Dragon board. And it also have a potential of embedded programming for automated control in various environments. Lastly, it also have a capabilities in practical automation and establish a basis for future improvements, including the integration of sophisticated features. From what I meant, the integration of sophisticated features for our mini project, time-based light controller working principle is just like real-time clocks or energy management system, so that it can develop more resilient and sustainable solutions. Thus, we have to maximize using more lights and avoid energy waste by using our mini project.